This is Scott from KIG. It is February 1st, 2017. We're going to do a runoff today for our New York customer with a 7.5 ton cold shot air-cooled water process chiller. This unit here does not need the covers on for proper airflow like other units. So we do have the whole bottom section here repainted and touched up, and we have these side covers here, just so you know, and we have this front cover here also. This unit is a 7.5 ton. They call it the ACWC-90, serial number M031712-1. It's a 2012 with the newest R410a refrigerant and a 1.5 horsepower process pump. We're just going to go ahead, and we have power to the unit here, and we're just going to turn on pump. And when you first start up the unit and power it up, it is phase dependent. So you're going to have somebody here, and they're going to toggle it to the pump only position just for a second. And while you do that, you're going to go down and have somebody look at this pump here and take off the end cap on the pump there, or you can actually look in there when you toggle the pump on and off and make sure you have the right rotation. There's an arrow here. Most pumps looking from the back end are clockwise, looking at the shaft end, as is this one here. So that's important, because you can't run you don't want to run the pump backwards. It will run backwards, but more importantly, you don't want to run a three-phase scroll compressor backwards. We're going to go ahead and start chilling here. So we can just switch it over to cooling cycle. We went ahead and I just set the set point up to 100 for no other reason than to elevate the temperature in the stainless steel tank for this test. On this controller here, and this is an outdoor rated chiller by the way, and this is a weatherproof controller. On this controller, you just simply press the function button. Don't play around with the SMT button. That's a smart test. You can get yourself in trouble as far as changing some functions there. So all you want to do is press the function button, and that brings up at the set point, and we're going to bring it down to 50 degrees. I believe this customer is going to run straight water. Never run a chiller below 48 degrees set point with unless it's straight water, or with straight water. In this case here, I'm going to bring it down to 48 for the test. And so we're starting to chill now, and those indicator lights simply shows that the compressor is on, and it's showing us that we're a little bit out of range right now because I brought the set point down so much lower than what the existing temperature was. So this has this 1.5 horsepower process pump. It draws off that tank here and comes up and comes out. So your lower fitting here is out to process. Your upper fitting is the return, and that return comes back into the tank here where the refrigerant to fluid heat exchanger is. This here is a Y strainer. You need to take that out regularly just to clean. It's a mesh in there to make sure there's no particulates in the flow. This here is an actual flow switch to make sure we have flow. If we lose flow, the chiller shuts down. This is our stainless steel tank here. This unit has a brand new brazed plate heat exchanger submerged in it, and that's our lid. It'll ship on top of the tank. So right now we're just cooling down the tank contents. So we have this loop that we set up here for the test. So you can see we're down to 70 degrees right now. When we get to the set point, usually there's a differential or a little bit of overshoot. It might go a degree or two below. Then it's going to wait till it goes a few degrees above before the chiller turns back on. As I mentioned, this unit is outdoor rated. By the way, up here are the controls, but this will all be, or some of the electronics, this will all be covered by the front top of the chiller, which is there. And here's another unit for another customer, by the way. That one's going to a brewery. This here is what we call a P266 fan speed control. That's part of the low ambient package, which allows this to run outside even in the cold weather. It controls the fan speed based on pressure, something that you need for colder weather climates. This chiller here, when you do get it, you want to put on a shut-off both on the inlet and outlet. You also want to hook up a tiny little bypass with a third shut-off. I just set up this little mock display on the floor here. I grabbed some PVC stuff out of the bin so you can understand what I'm talking about. So you're going to put a shut-off on the outlet and a shut-off on the inlet. Then put some T-fittings, okay? And this can be brass or Schedule 80. And hose, and then connecting those two T-fittings, you want to make a line and put another shut-off there. That's a flow bypass. So if you're pumping out to your process and your process is either too restrictive, or if your process even closes up completely sometimes, that's when you would tweak open this bypass to make sure your chiller has enough flow returning back to the heat exchanger, because what you don't want to do is stop or minimize the flow and pressure back to the chiller. You can see here we're already at 56 degrees. We like these units because they run very quiet, and you can see here this is our small chiller test area. That's another 7.5 ton, as I mentioned, and here's a 5 ton and a 5 ton that we're working on of this manufacturer. This unit's going to ship on this skid that we made, and we'll get crate sides that we're going to fully crate it, even though it's just going 3 hours away. We want to make sure everything survives the journey. This band you see in the compressor, that's what they call a crankcase heater. So even in the winter, yeah, that heater is always on. It keeps the refrigerant warm in there. You never want to get the refrigerant too cold, particularly in an outdoor application. So it's important here that if you want the chiller off, you just turn it off here, especially in the winter. If this chiller is outside in New York, don't disconnect the power at the disconnect on the wall, because that means it's going to get too cold here for a cold startup. As long as there's power coming into the unit, even if this is off, as long as there's power coming into the unit, this crankcase heater is on, and we always want that on. It uses very, very little energy, and it's hot to the touch, but not crazy. If it ever goes into high pressure alarm, which could be due to like a dirty condenser coils, that's the high pressure reset switch right there. So the unit just turned off. It went, like I said, a degree or two below set point. That's about it that we want to talk about here. We've been running it for a week. As I mentioned to the customer, we like to... Oh, one more thing. You have some fittings that we're going to strap down here. That's just to allow us to ship it in a more compact crate. That fitting and that cap, which will be attached to it, is basically the viewing for your tank fill. Or I guess you could call it's the fill. In addition to the sight glass that's going to be on the side of it, when you on this unit here, you can see that elbow fitting just screws into the side of the tank, and that's where you would fill and actually see your glycol level too. It's one of our favorite designs for quick monitoring of glycol level, assuming that if you don't have a sight glass like that. So in your unit here, it's shipping like that. Again, it'll be inside a crate. You do have the glycol level sight glass. But when you get it, just screw that elbow there onto it. So this unit is solid, well tested, brand new heat exchanger, newly painted on the bottom. It really didn't need it, but our technician Dan and Dana wanted to make it look pretty in addition to making them run perfect, and that's kind of cool. This is Scott from KIG. Our website is kigsales.com. Thank you for watching what is probably our 300th chiller runoff video, if I had to guess. Take care.